Hello friends, this is Professor Rahul Bhavne and in the subject of heat transfer, today we are going to see heat exchanger, its classification and its fouling factors. So this is a basic concept of heat transfer. So let us see. So what is a heat exchanger? As its name suggested, that means it is some kind of device where heat is exchanged. Now heat is exchanged, that means in between two mediums. So heat is exchanged in between two mediums, and as per the natural law, high temperature fluid to low temperature fluid. So heat will be definitely exchanged from high temperature fluid to low temperature fluid. So heat exchanger is a device used for transferring heat from hot fluid to cold fluid through the metal partition or direct mixing. Now, why it is said a metal partition? Because if we don't want direct inclusion of two mixtures, two fluids, suppose any plant is there and it is using oil as a lubricant oil. So after use it become hot. So we supply that oil through a condenser, and in condenser with the help of cooling water we cool down that lubricating oil and recirculate back to engine again. So in such kind of heat exchanger we can't afford the mixing of water and oil. So we will use some kind of metal partition. So one side of metal partition there will be a water flow, and on second side there will be oil flow, and during its flow it will transfer from hot fluid to that metal partition and metal partition to cold fluid. So there must be a metal partition, but some kind where it is required direct mixing. Now direct mixing means just like a water towers where we allow hot water to drop down as a shower, and there are number of blowers are there which blows surrounding air. So surrounding air come in a direct contact with the water, extract the hot that is temperature heat from hot water, and air get lesser density and move upward. So likewise in a cooling tower we use surrounding air with the help of direct mixing kind of heat exchange and cool down the water. So definition: heat exchanger is a device which uses transferring heat from hot fluid to cold fluid through the metal partition or direct mixing. In this, hot fluid get cooled and cold fluid get hot at the exit of the device. Now this is the picture of geyser, that is water heater, but this is not an electrical geyser, it is a gas geyser. So as you can see here, there is a one cold inlet, cold water inlet. So water will be taken into the geyser part here, and when we switch on our gas burner, so hot flame gases will travel through this center pipe. Now there are two fluids, one is the liquid form, that is water, second are gaseous, that is flames, smokes. So hot flue gases, gaseous form. So this hot flue gases heat up this tube surface, and from this tube surface it will travel into this cooling water, and after some time we found that water get warm. Okay, so here we use a metal partition in the form of tube, and heat is transferred from hot gases to cold water. This is one of the basic application of heat exchanger. Many times it is asked in your practical exams. Now second most commonly and technically used, that is a radiator, any automobile radiator. So this picture showing the arrangement of a radiator, where when we run engine get heat up, then we require to cool down that engine, so we circulate a cooling water. So cooling water is circulated through this engine cylinder block, get heated, that warm water then shifted to upper heater of this radiator. That's mean this portion. Now hot water is here, we require to cool down this. So hot water through these radiator tubes will travel obviously by gravity only, so from top to bottom, and meanwhile there will be a cross airflow. By cross, because water is flowing straight way vertical, and air will flow in a 90-degree cross. So when air passing through this radiator fins, so it will extract the heat from this hot water, and water get cooled down, and then cold water we recirculate again to the engine. So this is a second very basic application of heat exchanger. Now let us move ahead for classification of heat exchanger. This is also a very important question, because many times it is asked in university exam to classify heat exchanger, and for 6 marks we have to give the proper classification. So first category, according to the flow arrangement of fluid, how the flow take place in a heat exchanger. On the basis of that there is a classification. So according to the flow arrangement of fluid, so first is parallel flow heat exchanger. So in parallel flow heat exchanger, as the schematic showing that, suppose this is a hot fluid passing through this inner tube. So it is passing from left to right, and there is a one shell where cold fluid is coming in and then travel along the length of this tube, and during its pass it will gain heat, because during its pass whatever be the hot fluid, definitely it is going to deliver heat to this pipe section, and surrounding this pipe section there is a cold fluid, so cold fluid will extract heat. So cold fluid during its path from inlet to outlet get heated, gain the heat, and move out as a outlet, but it will be a warmer. Okay, but in a particular this section of a heat exchanger, if we observe that, then hot fluid and cold fluid are moving parallel in the same direction. So this is called parallel flow heat exchanger. Remember, we have a numericals based on parallel flow heat exchanger, counter flow heat exchanger, and cross flow heat exchanger. So these are very important, because on the basis of this there are numericals. Now the second is in the same category, flow arrangement, counter flow heat exchanger. Now obviously counter means opposite direction flow. So in opposite direction flow, suppose hot fluid is moving from left to right, and cold fluid is entering from bottom, and it will travel towards left, and during its travel it will gain heat and move out from the left end. So in the particular heat exchanger section, if we observe, then hot fluid moving right, cold fluid moving left, that means it is in opposite direction, so it is called as a counter flow heat exchanger. So parallel flow heat exchanger having some different advantages, some disadvantages. Counter flow heat exchanger having its own advantages. So we will see later on as we move on to numerical portions. Okay, right now it is a very basic classification. So one is parallel flow, second is counter flow. Now the third is cross flow. In the same category, flow arrangement, third is cross flow. Cross flow heat exchanger. So there are different types. First is unmixed cross flow. Unmixed means there is no mixing, direct mixing of fluid. So that is called unmixed, and this is the application of unmixed. It is similar to the radiator. So hot fluid will passing through this tube, and cold fluid or air is passing over the tube but in 90-degree direction. So it is called cross flow. Now in this particular heat exchanger, hot fluid enter into this pipe section, and throughout the pipe section it will travel in the same stream. So this hot fluid cannot be mixed with the water of second tube or third tube. So particular portion of water will flow through its respective tube only. That means hot fluid itself, it is not mixing with other hot fluid tubes. Secondly, cold fluid or air, it is moving through this, and there are baffles. So due to baffles, air cannot be mixed with the second layer of air. It is entering, and due to baffle, it will travel through the same channel. So that means neither hot fluid is mixing nor cold fluid is mixing. Okay, so it is unmixed cross flow. Remember, when I said unmixed, that means cold and hot fluid not mixing with each other as well as in the same stream also. So hot fluid is not mixing with the other portion of hot fluid, or cold fluid is not mixed with the other portion of cold fluid. So it is called unmixed, and basic application is radiator. Second, cross flow heat exchanger, where it is a mixed cross flow. Remember, we said mixed cross flow heat exchanger when at least any one fluid is mixing, then we say it is a mixed kind of heat exchanger. So here the same application, hot fluid is moving through the tubes. So hot fluid is not going to mix into the second tube fluid. So hot fluid remain unmixed. But cold fluid, as there are no baffles tubes, so cold fluid when enter, it will move over the tubes, and it can randomly move anywhere. So cold fluid can be mixed. So as I said, any one fluid, if it is a mixed kind, then also it is a mixed cross flow. So this is a mixed cross flow heat exchanger. Now the second category, according to the heat transfer process between two fluids. So first is direct contact type. So if heat is a transfer between two fluids, if two fluids come in a direct contact. So as I say in an introduction part, so this is a cooling tower. Where it is used? As I said, there is a condenser to cool down some hot liquid or oils. Okay. Now for that cooling purpose, we use water. Now water source is limited, especially in industry. So we can't afford to supply each time the new cold water. So outlet of any condenser is supplied to cooling tower here. Now this hot water from condenser is supplied to cooling tower at top heater, and where it is come out in the form of spray. Sprinkles are there. So this hot water, due to gravity, heaviness of that droplets, it moves downward, and there are blowers are provided which blows surrounding air into this cooling tower, and this surrounding air, when come in a contact of this hot spray, its density become lesser, and low density air will move upward. So in this process, hot water lose its heat, cold air gain heat and move out. So ultimately we cool down our cooling water and recirculate to condenser again. So in this particular type of heat exchanger, there is a direct contact. This air come in a direct contact with water. Second, in the process of heat transfer, second is the transfer type. That is also called as a recuperator. Remember, a recuperator is the word, because external many times ask recuperator is which kind of heat exchanger. So it is a transfer type heat exchanger. Now, what is the recuperator? In a transfer type heat exchanger, two fluids are kept separate and they do not mix when they flow through it. Heat is a transfer through the separating metal wall. So two fluids are there, but they are separated by any partition. So hot fluid will deliver its heat to the partition, and from partition, cold fluid will gain the heat. So such kind of arrangement is used by transfer type, because partition member is actually transferring heat from hot fluid to cold fluid. So such kind of arrangement is there. This is a air preheater. Normally in industry it is used where there are boilers or furnaces are there. So to supply air to the furnace, so it is prefer to supply dry air, because wet air is there, then heat is utilized to first dry the air or remove the moisture. So heat is lost. So it is preferred to provide a dry air to the furnace. So whatever be the hot gases moving out through the chimney, so in that chimney there are provided a tubing sections, and air will intake from that tubing sections, and during its path hot gases deliver heat and that air get preheated. That means moisture are removed out, and then dry air is supplied to the burner of that furnace. So here tubings are there, that is a partition part. So this kind of heat exchanger is known as a transfer type heat exchanger or recuperator. Now according to the again heat transfer process, storage type. Now in a storage type, it is not like a transfer type heat exchanger where heat can directly transfer to second fluid. Hot fluid heat is stored in some matrix, then after some time it will deliver to cold fluid. For example, this is a matrix type heat exchanger, and that is called a regenerator. So recuperator is a directly supply heat from hot fluid to cold fluid, but a regenerator, it takes some time interval. Now this is a matrix type, a regenerator or storage type. Here as you see, hot fluid inlet is there with one knob. Then hot fluid will travel through these channels, and these channels are surrounded with some matrix. It is a metallic matrix or ceramic matrix, and then hot fluid will move out through this. Again there is a cold fluid channels, cold fluid in with there is a knob, then cold fluid will move through these channels only and move out here. So in this particular regenerator, how it operates, so first we close the cold fluid knobs, so cold fluid cannot be entered, and open the hot fluid knobs. So hot fluid will enter when during its pass, its matrix or metal mesh will get heat up, okay, and then hot fluid after delivering heat, it will move out through this knob. After suppose 10 minutes, this matrix get heated to sufficient level. After that particular time period, we close hot fluid inlet wall and exit wall. Now there is no hot fluid, but this matrix get heated because of this hot fluid gases or hot fluid passes. Then after when hot fluid section are closed, we open a cold fluid. Now cold fluid knob is open, so cold fluid will enter, and during its pass through this matrix channel, now matrix is heated, so heat is delivered to cold fluid, and cold fluid get heated and move out through cold fluid outlet wall. So it is an intermittent. For particular time period, allow hot fluid, due to hot fluid matrix get heated, then after stop the hot fluid flow and allow cold fluid. So during passes, cold fluid cool down this matrix, that means gain the heat. So this is called storage, because heat is stored in the matrix for particular time period. So storage type heat exchanger, or most commonly it is called regenerator. Now another storage type that is a heat wheel. Remember, this is also a very basic application of storage type. So there are two types, either matrix kind of heat exchanger, that is a regenerator, or a rotary wheel or heat wheel, it is called heat wheel. Now here there are two boxes, okay, and one wheel. And this wheel also, just like a matrix, there are pore holes. So when hot fluid is moving in, so during its path, it will heat up this half portion of wheel. And during its path, it will deliver heat to this half portion of wheel and move out. After some time, this wheel get rotated and heated portion will come upward. And when cold fluid moving through this heated portion, it cool down this wheel and gain the heat. So during cold fluid pass, bottom surface of wheel get heated. So it is continuously delivering heat. But when heat is storing at the bottom section, at that particular time period, cold fluid cooling down top portion. After some time, again it rotate, again hot portion move upward, cold portion move downward. So likewise, so regenerator type, it is intermittent. It can provide continuous flow, but rotary wheel, it can provide continuous flow. Now, according to the geometry, next category, geometry. So tubular heat exchanger. So tubular, that means tube in a tube. Such kind there's parallel flow or counter flow heat exchanger. Tube in a tube. So there will be a inner tube flow as well as annular space flow. Next, shell and tube. So this outer casing is known as a shell. It is a bigger in size as compared to tube in tube. And there are number of tubes. Now imagine, suppose hot fluid is entering and passing through this tube, and cold fluid entering into this shell, but due to this partition it can't move here. So cold fluid will enter, pass along the tube and move out, but during its pass it come in a contact for a very small time period, so it can't gain that much heat. So in shell they provide a baffles. Now due to these baffles, cold fluid cannot move straight away towards outlet. It will move like this, then due to baffle change its direction, again move over this tube, again change direction. So total path is increased. So as cold fluid remains in contact with hot fluid for more time, so more temperature will gain is there. Okay, so this is shell and tube type heat exchanger. Now here hot fluid is entering and straight way move out. So this is single pass. So this is called hot fluid single pass. Cold fluid entering and moving out. So this is cold fluid single pass. So shell one pass, tube one pass. Such kind of shell and tube heat exchanger. Sorry. Now shell and tube type heat exchanger, one shell pass and two tube pass. So shell is one shell pass, two tube pass. So whatever be the fluid passing through tube having a two passes. So hot fluid entering here, and because of this partition it can move this side. So hot fluid will enter and pass through this top tube only. And when it come to right end, because of this close enclosure, it can't move back, so it will move through bottom tubes. So hot fluid is moving first right in a first pass, then in second pass it will again move back to left. So we extend the total flow length of hot fluid. So this is two tube pass. Two tube means number of tubes now. It is a number of passes. So first right one pass, then left two pass. So two tube pass. One shell pass means there is only one. So shell fluid enter at left and due to baffle and move out on right. So there is only one pass. Even though there is a direction change, but there is not a pass change. That means it is not again move to left side. It is entering on left and move out from right. So one shell pass, two tube pass. Another category, two shell pass and four tube pass. So there are two shells. Okay. So hot fluid enter, then from tube it will first move to right. In the same shell again it is moved to left. That means there are two passes. Whatever be the outlet of this first shell will enter to the second shell, again move to right, third pass, and come back to left, fourth pass. So two shells are there and four tube passes are there. Now shell pass, how shell pass? So cold fluid enter at left and move out from right of first shell, and this outlet will enter into the second shell at right and move out from left. That means cold fluid one pass in one shell and second pass in second shell. So two shell pass and four tube pass. Now according to the geometry, so third is fins type. Okay, so in fin types, small number of tubes are there, but as diameter of tubes are so small, so it can't provide that much surface area for cooling. So we use fins. So these fins plates are attached. So now whatever be the fluid passing through this tube, tube surface get heated and that tube will heated these fins. Now when cold fluid passing over these fins, so total heat surface available is more, so it can provide that much cooling, or it may provide that much heat to gain the gain by cold fluid. So fin type heat exchanger. Now plate type heat exchanger. Now here in this there are thin plates are there, and it is sandwich in between, and during sandwich arrangement are made such that one plate section is made for cold fluid and second plate section made for hot fluid only. So fluid cannot be mixed. Now here from the bottom this blue arrow showing cold fluid. When cold fluid is moving to this plate, there is a portion where cold fluid can enter here. So cold fluid enter this plate and move upward, and some part of cold fluid move further, but it is not entering to second plate, it is directly entering to third plate. Likewise again it is move ahead and enter into this plate. Now hot fluid, this red arrows, it is not entering to first plate, it is entering to second plate and move down. Then some portion move ahead and next. So hot fluid and cold fluid passing through alternate plates, and these plates are so close to each other. So hot fluid during its pass, it will deliver heat to cold fluid. Obvious, there is a partition of this plate. So cold fluid density will decrease and low density cold fluid move upward and come out as a outlet. Hot fluid during its pass, it will deliver heat, become colder and move out from bottom side. So this is a sandwich plate kind of heat exchanger. Now in geometry also there is a compact heat exchanger. Now why we require a compact? So in many applications, just like your mobile phone or your laptop, so small devices, but it required cooling. So we compact the heat exchanger cooling system so small that it is come in a next category, that is called a compact heat exchanger. These are special type of heat exchanger in which the heat transfer surface per unit volume, that is called a density, is very large as compared to all other types of heat exchanger. That means it having a very small volume, total volume of heat exchanger, but it provide a large temperature change between two fluids. So these are some examples. So very small sandwich. So volume wise it is very small, but it gives the sufficient cooling, that is temperature difference. So might be such kind of flat tubes or circular tube with fins, or this circular fins, or this kind of matrix kind, but it is in very small size. So that is called compact heat exchanger. Now the last portion of today's video, that is heat exchanger fouling. So heat exchanger is what? It is just simply a exchanging device. So might be you observe as the image showing that this is a one heating coil, water coil heater. Many students use, mostly in hostelite student. So to heat the water, we have that heating coil. We immerse in a bucket, water filled with water, and then we start. So when we purchase it, it is just like new one. But after some time, after 5 or 6 months, if you observe, so there is a scaling, and this hard scaling behave like a barrier for heat transfer, because hot water, water cannot come in a direct contact with this metal surface. So it will come in a contact of this scaling, and this hard scaling behave like a barrier to heat transfer, and this is called the fouling. That means because of this scaling or layer formation, heat exchange is reduced, because heat is not transferred directly to water. So such kind of phenomena are observed in heat exchangers. So this is a new one. After some use, you can observe that almost all holes get plugged due to this scaling. This is another picture showing that internal section. So whatever be the hot gases passing through these inner tubes, but outside fluid after some use provides such kind of scaling, and because of this heat exchanger efficiency get reduced. That means at the beginning, whatever be the heat is transferring, it is a large amount. That means heat exchange is large, hot fluid to cold fluid. But after such kind of scaling, heat transfer rate decrease. So even though that same size, but we get a lesser heat amount. So that is called fouling. Now fouling having a various types. So first is precipitation fouling. In this type, solid deposits on the heat transfer surface, mostly the surface exposed to water. So just like a water heater coils. Probably a layer of calcium base deposited on the surface at which boiling occurs. This is due to the dissolved impurity of water. So water having its impurities, so anywhere where you are using water, definitely after some time that water impurity forming a layer, and that is called fouling, and that fouling is known as precipitation of fouling. Now what is the remedy, how to treat it? So if this fouling is on outer surface, okay, then it may remove by scratching, and surface can be cleaned off by chemical treatment. So if it is on outer surface, you can use any sandpaper and you can remove it out. If this fouling is on inner surface of small diameter tubes, then it is only clean off by chemical treatment. So we have to use some chemicals. But in general, that is day-to-day life, if you found scaling, precipitation falling on your water heating coil, there is a very easy way. That heating coil is made for water. That's mean whenever it is deep in a water, it is not harmful. Okay, so how to remove that precipitation? So have a one bucket water, cold water, and switch on your heating coil, but don't immerse into the water. Let it be red hot. Okay, so kept it outside in air. Switch on your coil. It will become red hot, including with its precipitation, and then suddenly put that red hot your coil into the water and switch off your that heating coil. So what happen, your precipitation get red hot. Okay, so thermally it get expand, and as soon as we put into the water, so suddenly it get contract, and that contraction form a cracks of that precipitation, and that your whole precipitation layers get cracked, and if you shake it, so your all layer get removed. But that is not a technical way. Now move on. Second kind of fouling is sedimentation of particulate fouling. The deposition of solids suspended in the fluid on the heat transfer surface due to gravity is called sedimentation fouling. And the solid ash, soot particle, dirt particle in the flue gases and air accumulated on the heat transfer surface, then it is called as particulate fouling. Now the simple example. Many times you observe that your silencer, after some particular time, you have to regenerate it. That means we have to remove the carbon particles. Why we require a removal of that carbon particle? Otherwise your silencer not working properly. So that carbon layers forming a barrier to that mesh particle inside the silencer. So it can't remove that, arrest your particles, smoke particles or sedimentations. So it will form a one carbon layers, and it will behave like a barrier for heat transfer also. So such kind of layer formation or smoke, that black smoke formation, is known as particulate fouling. Treatment for sedimentation fouling: use water after treatment. That means filtering and impurity removal. That means whenever you using such kind of system, so always use water after filter. That means there must be a water filter before entering to your heat exchanger. So that filter will remove the solid suspended particle, and for particulate fouling, that's when carbon deposition, it is prefer complete combustion and periodic cleaning of deposition, because carbon is mostly, it is not completely burn particles. So always prefer your system should burn completely, whatever be the fuel is there, and definitely that even though it is completely burned, but it will form a carbon layers. So periodically we have to clean that. Chemical. So chemical, it is generally called as corrosion fouling. So chemical fouling or corrosion is the deposited material produced by chemical reaction between material and its environment, and the heat transfer surface may produce product that fouling the surfaces. So it is called the rusting. So whenever we use water, so we prefer copper tubes, not the MS tube, because it soon it will form a corrosion. Okay, so that corrosion layer will be a one kind of fouling which barriers to heat transfer. Now, how to treat? This can be avoided by coating metal pipes with glass or using plastic pipe instead of metal, if possible. If it is not possible, then we plated it, copper plating. So you know that what is a plating. So electroplating. So we provide a plating with such material which oppose the corrosion. So if there is a MS tube is compulsory, so we will use MS tube with copper plated. So copper will avoid such kind of corrosion. Now biological fouling. So what is a biological fouling? So many times that algae is formed. Okay, even though if you visit any IC engine setup is there, cooling water, and there is a glass tube rotameter is there. So if you found after some time of water flow, there is a one green color of algae formation is there. That is called a biological fouling. So this result from the deposition, attachment, and growth of macro or microorganism to the heat transfer surface. This is especially growth of algae in warm fluids. So algae formation is there. How to treat? This can be prevented by chemical treatment. So put such kind of chemicals which are stop the growth or formation of algae. Then freezing fouling. So fouling is basically that portion or that layers which provide a barrier for heat transfer. So freezing fouling. So it is basically used in refrigeration or deep freezer. So even though in your household refrigerator, if you keep your refrigerator on and go for a vacation of 1 month, and after coming back you observe that that chiller portion where you made ice, so there is a ice layer form inside that evaporator section. So due to that icing, heat cannot be transferred easily. So ice layer also provide a barrier for heat transfer, and that is called freezing fouling. Freezing fouling is due to the freezing of a liquid or some of its constituent or the deposition of solid on the subcool heat exchanger surface. And this can be removed by defrosting the system after particular interval. So in a previous refrigerator there was one button, defrosting button, but now it is come with an automatic switch off. So automatically you're defrosting it on and freezing, that is icing layer, remove. So today we just cover a classification of heat exchanger and foulings. Remember, if it is not that much important, so I will not cover. But in a practical oral exam point of view, many questions based on this portion only. Okay. So thank you.